Okay, this lab demonstrates how mechanical work by the friction between this nylon rope around the cylinder is being converted into heat energy. So the idea here is to rotate the cylinder in this apparatus so that the thermistor inside this aluminum cylinder changes the resistance inside, as consequently the temperature changes and heat energy is produced. So we're gonna cool this down below 5 degree than the room temperature, and after the work or after the frictional work done on it, we will rise it by 5 degree than the room temperature. That's what explained in the manual. You can read it out. And the apparatus here is this crank handle on which the axle, this cylinder is fixed, so that only the cylinder moves when we rotate the handle. And there is a counter on the other side which counts the number of turns. And there is a metal strip when contact with these two solder dots on this cylinder, it is pressed, and when it is moving, there is some change in temperature or some change in resistance that thermistor signals to the multimeter. And by the reading of the values of the resistance on this multimeter, we get the corresponding temperature value from the table given in your manual. It's along with the curve on page number 5. So this is how it works. And to start up, you need to have the mass of the cylinder, and in order to have this, we have a digital balance, and I'm finding for you. Its mass of this cylinder is 203.5 gram. 203.5 gram. It's gram. Make sure you fix the unit in standard units when you calculate them. So the diameter of this cylinder, I'm going to measure it for you. This is the inside diameter in which this nylon rope sits on. So you need to find inside diameter. So you fix the vernier. We use the vernier caliper for diameter. It's between 4. It's between 4.7 and 8. So it's a 4.778, I would see. 4.78 from your vernier reading centimeters. 4.78 centimeter is the diameter of this cylinder that you need. So you need to cool it down by 5 degrees than the room temperature. The room temperature now is like 20 degrees Celsius in here. So you got to cool it down. So I am wrapping this in a polythene bag and cool it in a cold bath of ice. You need here is a mass of bucket and weight inside it. So I'm again using this digital balance to find its mass. It's 118.6 or 118.7 grams, only the bucket. And you need to add weight on it, and I believe you need to add these two standard weights, each 2 kilogram, each same weight of 2 kilogram. And we have this equation in this table 1. This is the number of tons column, right? You can see in the equation for work done, that's mechanical work, and the parameters inside the parenthesis is the constant term for this work, and only the variable here is the number of tons. Number of tons here is the number of rotations you make by the handle in order to rotate the cylinder. And D is the diameter, as it mentioned here, big D, and big M is the mass of the bucket plus weight on it, and G is acceleration due to gravity, close to 9.8 meter per second square. And N, you start with 0, and in each trial you increase it by 20 number of tons. Okay, this is a cylinder. I have just taken it out from ice bath. So this is cylinder and pretty lower than room temperature. So I am mounting it on the apparatus to the solder dot towards the metal strip, so that you can find contact between them when you rotate it. So it's a little hard, but still. So there is a lock. Want to fit inside that lock, and this is a screw which is tight on this side, and multimeter is set to 200K. That means that's the range. You can go until 200 kilo ohm. And so 2 windings around this rope should be enough. And I'm adding these 2 standard weights, each 2 kilogram, into the bucket. So the total mass of the bucket is 4 kilogram plus the mass of the bucket. So from the equation here for weight, we're going to vary the number of tons, and the parameters inside the parenthesis is constant. So for this table 1, I would start from number of tons, 0 in the beginning. So the reading on the multimeter is 184.3. 184.3 thousand ohm is equivalent to temperature close to temperature 13 degree or little lower than 13. So you have to note this resistance value when the number of turn is 0. The value is 181.3. So you need to be careful. 181.3 thousand ohm. Yeah, or you can wait. So you need to start at low temperature or below 5 degrees, then the room temperature would be good.